Hello, I'm Tom Hollingsworth, and welcome to Networking Field Day. We're here in sunny Santa Clara, California with NEC at Networking Field Day 13. We're also joined by a group of Networking Field Day delegates around the table who represent the best and brightest minds in the networking industry as bloggers, podcasters, writers, and speakers. They have been invited to this event to take part in discussions, to ask questions, and offer their opinions on technology. If you'd like to learn more about this event series, including how to become a presenter or a delegate yourself, please go to our website at techfieldday.com. If you'd like to see more videos about technical subjects like this, please visit our YouTube channel at youtube.com/techfieldday.
Hello, my name is Liviu Pinchas. I'm the product manager for NEC SDN line of products. The first demo that we will present you today is for our solution for SDN combined with unified communication. Before we run the demo, we would like to show you what this solution is about and what problems it tries to solve and how. So, of course, we are all familiar with unified communication. We use Skype, we use WebEx, and also many of us, we use NEC UCC, Unified Communication Controller, which is the third largest solution in the world in terms of market share. So at the beginning, there were simple requirements like completing phone calls, but now we want to do video conference and screen sharing, and also different other value-add services like 911 calls, attendant calls, call centers, and so on. This puts a lot of stress on a network. All these tools work to some extent on a simple, unmanaged Ethernet network. But the quality of experience, it's not good enough for today's requirements. So the layout of the system, it's very simple. We have a network of Ethernet switches. And then we have hard phones, IP phones, or soft phones running on laptops, all terminating calls. And we have a server that runs management software that initiates and manages the calls. So in order to improve the quality of experience, the first thing that was done was a very rough traffic management. So let's say all voice is priority 1, all video is priority 2, data is priority 3, and this helps a little, but not much, because things are a lot more complex. There are many calls, and not all the calls are of the same importance. So even if we have 2 voice calls, a person talking with the company's most important customer, it's higher priorities than a call between 2 guys that simply chat. So even the same type of data needs to be prioritized. So there is a need for much finer grained engineering of the network, not based on the type of data, but actually based on each and every call and its importance and urgency and so on. So that's the first issue. Much finer need for engineering of the network and management of the calls. The second problem is, no matter how well the network is engineered and managed, things happen. So the call was established, nice video call, it works fine. And at some moment, your neighbor starts downloading some video, and the quality goes down. Now, people have a short fuse, a limited tolerance for decrease in quality of service. So when the call starts being of low quality, we have 1, 3, at most 5 seconds to bring the quality back, to solve the problem and restore the quality. Otherwise, the user will just finish the call and send an angry email. So that's the second problem. They need to dynamically control what happens with the call and in case the quality is affected, to take measure to improve it. So this is our solution. This is how we address these two issues. The network that we recommend, it's a network based on programmable flow switches. These are switches that can come from NEC or can come from any of our partners, one of them being Dell. Switches that can be controlled through open flow. And we have the programmable flow controller on the right side, which is our SDN controller capable to build a global view and manage globally this network of switches. Then on the left side is a unified communication server. It's the software that is responsible to initiate and manage the calls. Now, this unified communication server has a huge wealth of information. It knows all the calls when they happen. It knows what the importance of the call is. It knows the quality of the call, the jitter. So all this intelligence needs to be taken advantage of. So we have built SDN adapter, the block on the top, which pretty much takes the diagnostic data from the unified communication server. And in case it notices any issue, degradation in quality or other problems, it will instruct the PFC controller to take appropriate measure. And through this closed link, we are able to both set up and control the priority and the setup of all the calls, and also dynamically, while the calls are ongoing, to adjust as needed. So we will show you several demos that solve these two problems. First of all, the traffic prioritization before the call and during the call. And also traffic rerouting. So assuming that a call, for some reason, it's affected by congestion or other problems, we can reroute it somewhere in the network where there is a better chance to complete it successfully. So our setup mimics a real network. So we have on the lower side a bunch of switches that are capable to be controlled through open flow. And then on the right side, PF6800, our SDN controller. So the SDN controller maintains a map of all the network and status and controls each and every switches like one unit. Then on the left side, there is a UC server, the program that initiates and controls the calls. And on the top, the SDN adapter. So the way things go, the UC server will send instructions to clients that are on people's laptops or IP phones to initiate the call. It will start the call through one of the green arrows at the bottom of the slide. And at the same time, the UC server will send to the UC SDN adapter information about the status of the call. And the SDN adapter will instruct the SDN controller to take appropriate measure when the quality of the call is decreasing or there is any other issue with the call. This is done through the REST API. And then the SDN controller through open flow will take appropriate measure to readjust the switches in this particular case to route the traffic through another route.